Didn't record this part, can't record the previous part. But we're going over problem 52 on the homework. The mean value theorem for integrals. Instead of going from negative pi over 3 to pi over 3, if there's any way you can finagle as 0 as one of your limits of integration, do it. And here by symmetry, you can say, well, let's just take half of the area and multiply it by 2. Antiderivative of cosine is sine, and then you follow the details from there. You end up having to do a Mach diagram because cosine of c is equal to some number. I don't know what that number it is, but it is positive. The mini unit circle diagram gives me cosine inverse of a positive number will give me a quadrant 1 angle. Then 2 pi, or rather 0 minus a quadrant 1 angle will give me the quadrant 4 angle. We knew there was going to be a positive and a negative. Rounded to 4 decimals, here they are. Any follow-up questions on this particular homework problem? Mach diagrams show up when you least expect it. How I got the 2? Yeah, what I did there to get the 2, just to give you a visual on that. And a few of you have some side conversations going on. Go ahead and table those for now. And let's focus in on Sam's question. He's looking at negative pi over 3 to pi over 3. I would argue that by symmetry, this area in blue is equal to this area in green. So instead of going from negative pi over 3 to pi over 3 on the cosine function, cosine x dx, why not just take half of it? Let's just go from 0 to pi over 3 and multiply it by 2. That's the move I made. We had talked about doing that several times last week. We just did it again. You'll end up doing that a lot when you start doing these problems correctly. Any follow-up questions on this one? I'd like you to take a handout from like 2 weeks ago. There's still some problems on this handout. You recognize it. It's the one that's entitled the Fundamental Theorem of Calculus, or the first Fundamental Theorem of Calculus. Find that, take it out, and let's jump into the new material. So, in fact, I'd like you to try problem number 15 as a warm-up for what we're doing here. Problem 15, you may begin. By the way, the reason we call this a warm-up question is that it's just double-checking to make sure you know the fundamental theorem. If you know the fundamental theorem, then you know that this can be rewritten as f of 6 minus f of 3. Just applying the fundamental theorem, which, by the way, in case you forgot it, it says that the definite integral from a to b of f prime of x dx is f of b minus f of a. So, notice that f of 3 is given, so f of 6 minus 2 is 8. So there's nothing to do on this problem from here except add 2 to both sides. Notice how these really intimidating looking problems, if you know the fundamental theorem, they cash out to a number pretty quickly. Not a lot to it. Any questions on problem 15? Let's do the setup for problem 16. I'm just going to talk you through it. The main section of new material is number 17, solving differential equations. 16 is meant to be review, and if you put the G in vegan tomorrow, then there's real hope of getting this thing right. You might remember that in Algebra 1, you would factor things like this into x minus 3 times x minus 1. This factorization of the integrand is an indication that the graph of this function would have x-intercepts at 1 and at 3. And since the y-intercept is clearly 3, I mean, at this point, we're just ignoring the absolute value and just looking at x squared minus 4x plus 3. So the graph of this parabola would have a y-intercept of 3, and we see some symmetry in there. Notice that we're integrating the absolute value from 0 to 4. So we've got a blue area we've got to find, a purple area, and a blue area. But by symmetry, what do you think? Are the blue areas congruent, or are the area values equal or non-equal? Yeah. Not sure what I think about purple so close to blue. Let's make it green. Okay, the two blues have got to be equal by symmetry. And absolute value means that anytime you come across a negative area, you'd better multiply it by -1 to honor the absolute value. So I would argue that this problem, if your aim is to shed the absolute values, and that usually should be one of the earliest steps to get rid of the absolute values, I would take 2 of the areas from 0 to 1, and then I would subtract the area from 1 to 3, because the area from 1 to 3 will be a negative number. To honor the absolute values, we should turn that negative number into a positive number. So here's the strategy that I recommend for shedding the absolute values in problem 16. Of course, from here it's pretty straightforward. I think I've done the hardest part of the problem. The hardest part is to get rid of the absolute values. Then from here, I'm not actually going to finish the problem. I mean, it is 1/3 x cubed minus 4x squared over 2 plus 3x evaluated from 0 to 1. And then same thing evaluated from 1 to 3. I mean, just apply the evaluation term from there. But I'm going to write the word same. But the hard part is shedding the absolute values. Any follow-up questions on number 16? Trying to get our notes complete. By the way, as you're getting ready for the quiz on Thursday, it's not a bad idea to take notes and kind of refill them out, kind of do them fresh. Jack, go ahead.
Why are we subtracting?
Okay, it's because of the absolute value. It's like we're doing a total distance problem.
Should we add it then?
What?
Should we add it then?
No. This is like the velocity function. Velocity is a function of x. And if they're asking for total distance, then that means that when velocity is positive, if I'm in rectilinear motion, that's positive. When I'm moving positive, that should count as distance. Even when I'm moving negative, when my velocity is negative, which means I'm moving left, that should count as positive. The only way to turn a negative number, and this number is negative, just the integral from 1 to 3, just going to put a red line around the actual area. But this is a negative number. If you don't believe it, type math 9 of x squared minus 4x plus 3, comma x, comma 1, comma 3 into your calculator. It will come out negative. And to turn that negative number into a positive number, you are obligated to multiply it by -1. And that's why there's a subtraction sign there. That's the only way to honor the absolute value.
Wait, but we are including it though, so that would include it.
I would include it as a positive number. If we just went to the calculator and just did the integral from 0 to 4 without the absolute value, then it would give us a displacement. It wouldn't give us a total distance.
So it would be the blue part minus the green part?
Yeah.
But that's the blue part plus the green part.
This will be the blue part plus the green part, yeah. So that's why you're obligated to subtract the green part off. Further questions? Pretty cool stuff happening out there. And now for the new material. Here we go. Number 17. One example, but it's the first example of a major theme in the course, and it's called solving differential equations. All caps. Don't let that alarm you. Solving differential equations. Now, it's not a new concept, but it's a new application of a concept we've already learned. Solving differential equations. First of all, you need to know what a differential equation is. A differential equation is really any equation that contains a derivative. It could have one derivative in it. It could have multiple derivatives. But a differential equation is an equation with derivatives. And when they tell you, problem 17, letter A, when they tell you that a of t is 2t, the acceleration function is 2t, that's actually a differential equation. It's the differential equation dv dt equals 2t. Acceleration is a derivative of velocity. Now, in order to solve a differential equation, we integrate. Acceleration is derivative of velocity. So a of t is the same thing as dv dt. It's just another symbol for acceleration. Now, we're going to separate the v's and the t's before we integrate. The number one strategy for solving differential equations in calculus is called separate and integrate. It's a two-step process where step one involves separation of variables and step two involves integration. Now for the separate part. Let's multiply both sides by dt's. We're talking v's on the left, t's on the right. That completes the separate portion of the example. We separated v's on the left, t's on the right by multiplying both sides by dt. It's almost as if this is a fraction dv over dt.
Let's go.
I'm fine now. I just multiplied both sides by dt. Now, let's integrate. I'm going to slice between the 2 and the t because the 2 passes through the semi-permeable membrane anyway. It's going to come out front. So we have an empty canoe, self-driving, automated canoe. What is the antiderivative of 1 dv? Can someone tell me what that's going to be? It's a whole family of functions, by the way. What's the family? What? V plus c. We'll call it v plus c1. Over here, it's 2t squared over 2 plus a second constant. We'll call it c2. So the velocity, and that's what they're asking, by the way. I mean, we have to find total distance traveled, which means we have to find the antiderivative of the absolute value of the velocity function with respect to t, from 0 to 10. This problem calls for velocity. But they don't give us velocity, they give us acceleration, which is why we want to solve the differential equation to get v equals t squared plus c3. c2 minus c1 is c3, which I'm just going to call a constant. This is called a general solution to a differential equation. Every differential equation has both a general solution and a particular solution. Actually, many particular solutions. Please write the vocabulary phrase general. General. No, that didn't happen either. General solution is important vocabulary for talking about differential equations. That's what that is. A general solution is simply in the family of all the solutions, all the functions whose derivative is 2t. It doesn't matter whether it's t squared plus 1, t squared plus 7, this is a whole family of functions whose derivative is 2t. Now let's get the particular solution. To find the particular solution, we have to look at the family. T squared plus 0, t squared plus 1, t squared plus 2, t squared plus -1. Here's t squared plus c. We need to find out which member of the family contains the point 0, 6. So let's write down the general solution, which is t squared plus c, and replace v with 6 and t with 0. Solving for c, we get 6. Therefore, we found the member of the family. That member of the family is t squared plus 6. That now is the function that we can use to answer the total distance question up here. We can just integrate 0 to 10. I don't even need the absolute value because t squared plus 6 is never negative. So this is the math problem I'd have to do to answer part A, and it would also answer part B. So A and B are done once we evaluate this using the fundamental theorem of calculus. Now, I do want to just finish part C, and then I'll take your question, Jack. To find the position, change S of 2 to P of 2, because now in the AP test they use P for position. I would like you to take the answer here, which is V is t squared plus 6, and change it to dp dt. Would you please solve this differential equation using separate and integrate? It'll take 45 seconds, but let's bring this to closure. Take dp dt equals t squared plus 6, and the initial condition that P of 2 is 100, solve for P using separate and integrate. Just put the dt on the other side and integrate both sides. It's a pretty straightforward integral. It's level 1 difficulty. Just integrate both sides. That's t cubed over 3 plus 6t plus c. We have to solve for c. The general solution.
Would Kayla Bentley please come to Student Services?
They told us that, what was it, P of 2 is 100? So put 100 in for P and 2 in for T and solve for C. So 100 equals 8/3 plus 12 plus C. So C, it's 85 and 1/3. So class, the particular solution, this is the general solution. The particular solution is P equals 1/3 T cubed plus 6T plus 85 1/3. All right, the homework is homework 4.8. 4.8 is due tomorrow. You are dismissed.